All right, here we go. We're moving on. We're going to do number 2. It's on the next page. Even though it's not really number 2, it kind of is. Here's the deal. It's the same problem. No pictures. They're going to try to man up on me. You can try to man up on me? Give me a question with no pictures? All right, here we go. Let's do it. So what I'm going to do is I'm going to highlight everything that looks important. So I see a mass here. I'm going to highlight that before I even read. I see another mass. I'm going to highlight that. I see a speed. Oh, I'm going to highlight that. And I'm going to pen what they want me to know. What it looks like they want me to know is post-collision speed. After Hulk smash, speed. So here we go. First thing I do is I write all my stuff down. So I'm going to write the same stuff I've been writing, right? So momentum initial equals momentum final. So that's true for our closed system. We also know the momentum is mass times velocity. So if we know these two things, we know we have two objects, so we should have two of these. So let's do it. Right it from you. Mass times velocity. This is the initial of the first object. Mass times velocity of the other first object equals, because momentum equals momentum, right? Momentum in equals momentum out. Mass times the final velocity of the first object plus mass times the final velocity of the second object. Here we go. So let's go over the question. A brick is placed gently upon a 2.9 kilogram cart. So a 2.1 kilogram brick is placed upon a 2.9 kilogram cart, moving with a speed of 26 centimeters a second. Determine the post-collision speed of the combination of brick and cart. Here we go. Well, first thing we're going to do is we are going to plug in what we need to plug in. So, we know that the mass of the first object is 2.1. Parenthesis that. We know the velocity, we'll call it 0, because I guess it was placed gently. So we'll call that 0. Plus the mass of the second object, 2.9 kilograms, times the velocity, which was, you guys remember our velocity, it was 26. So centimeters per second, equals, so that's mass times velocity. Remember that's 2.1, that's not 2 times 1, plus mass times velocity equals, we're going to skip and rearrange this like how we did, how it's like mass plus mass of the second object times final velocity, right? So the first mass is 2.1 plus, I'm going to put a lot of parentheses here because the points can get confusing. So mass 2.1 plus 2.9 super parentheses times the velocity, which is the final velocity, right? So now let's do some adding. So 2.1 plus times 0 is 0. So the momentum of the brick is 0 plus 2.9 times 26. Let's calculate toward this. Here we go. So what is it? 2.9. Y'all see that? Yeah. Times 26 equals 75.4. Awesome. So 75.4. So that was our momentum of the cart, right? Equals 2.1 plus 2.9. So that is 5 times the final velocity. Oh, this is going to be an easy one, I think. Methinks this will be easy. So let's rewrite this again. 75. You still see this? 0.4 equals 5 times the final velocity. How do we get this 5 out? Well, I always do the opposite. So it's multiplying here, so we got to make it 1 so it like has no impact. I divide by 5, then I cancel. I got to do the same thing to this side, divide by 5. Since it has a point, I will just calculate this. So I'm going to do this. There's my 75.4 left over. I'm going to divide. Whoa, I don't like that. I don't like that at all. Let's just go straight to it. 75.4 divided by 5. gives us 15.08. So our final velocity equals 15.08 centimeters per second. And remember, if we want to make our answer in meters per second, we can say, because if you go centimeters to meters, you're going to move the decimal place 2 places to the left, so boom, boom. So this is the same thing as 0.151 meters per second. So remember, these are the same. This is the same answer. This is meters. This is centimeters. So whichever one you put is correct, we have successfully finished the problem. So that's easy. So all the rest of these should be pretty much the same. You know, more or less, this whole unit is going to be taking this original formula here, and they're saying, hey, this problem you got to find the final velocity. This problem you got to find the mass of this one or something. They're giving you different things and saying they need different things. That's every question. You just got to figure out what you got to do first and take it step by step. Awesome job. Goodbye.